Hello students, welcome back to Enamel Heroes. So today we are here with another topic, and that is extraction elevators. So let's get started. So basically, elevators are the instruments which are used in luxation or removal of the teeth or the tooth fragments which cannot be grasped by the blades of the forceps. Okay. So elevators are those instruments which is basically used to remove the root fragments from the socket, and these root fragments cannot be removed with the help of the forceps. Okay. So example is impacted tooth, malimposed teeth, roots, etc. So now let's see the parts of the elevators. So elevator basically has a three part. This is the handle, this is the shank, and this is the blade. Okay. Now let's see the principles, the mechanical principle on which these elevators work. So there are basically three principles. First one we have lever principle. Then we have wedge principle. Okay. Then we have wheel and axle principle. So now let's see these principles one by one. Okay. So lever principle basically has the three classes or the three types, I would say. So there is a small mnemonic for it, that is flea. Here F stands for fulcrum, L stands for load, and E stands for the effort. Okay. So just students, just learn this sequence. Just learn this word flea. Now the first lever, in the first lever the fulcrum is in between. And this side we have load and this side we have effort. So in the first class lever the fulcrum is in the center, and in the second lever we have load is in the center, and in the third class lever we have effort in the center. So this is basically the mnemonic flea. In first class we have fulcrum in the center, in second class we have load in the center, and in third class we have effort in the center. Okay. Now let's see the application of this principle on the elevators. So here as you can see, the fulcrum is in the center, then our tooth is the load, and effort means our grasping, when we are grasping the handle, that is the effort. And students, effort arm is made longer. This effort arm, as you can say, this is longer as compared to the load arm. So when we make effort arm longer, we gain the mechanical advantage. I mean, by saying that we gain the mechanical advantage, the ease of extraction the tooth is easier when we are making the effort arm longer. So student, this is a very important question. It basically asks in your viva, why the effort arm is made longer than the load arm in class 1 lever. In class 1 lever, I mean in elevators, when you are applying this principle on the elevator, that is the lever principle, why the effort arm is made longer than the load arm. So the effort arm is basically made longer in order to gain the mechanical advantage, so that there is a ease in the extraction of the tooth. So now comes the question, how much is the mechanical advantage in the lever principle? So the mechanical advantage is 3. Okay. So mechanical advantage is 3. I hope this lever principle is clear and its application on the elevator. In the center we have fulcrum, then one side we have effort arm, and so effort arm, while we are grasping, that indicates the effort arm, and our load, our tooth that needs to be extracted, is the load. Okay. Now let's see. Elevators basically they work on first class lever. This is asked in Viva. Elevators work on first class lever. The handle of the elevator, as I have already explained you, act as a effort arm. Act as a effort. So longer the effort arm, lesser will be the there will be the ease in extraction of the tooth. Okay. The working end which engage the tooth is the load. As I've already explained you here, the tooth is the load, and the tooth is basically acting like a load. Okay. Now, very important, what are the examples of the first class lever? So we have straight elevator and Coupland elevator. These elevators, they work on first class lever. Okay, this is very important. This is also asked in Viva. The elevators which work on class first lever. Okay, I hope this lever principle is clear now. And what are the Viva questions that comes from this section? So they basically ask you about the effort arm and the load arm. They ask you about the mechanical advantage, how much is the mechanical advantage, and they also ask you about the elevators which work, what are the elevators example which work on first class lever, and why the effort arm is made longer than the load arm, and all of these questions. Okay, I hope now the lever principle is clear. Now I am moving on the wedge principle. Okay, so in wedge principle, when we are luxating the tooth from its socket, elevator is applied between the bone and the, this is basically the application. This is the application of wedge principle. Okay. So where the elevator is applied? Elevator is applied between the bone and the tooth to separate the attachment of the pedial fibers. Okay. Now let's see this picture. Suppose this is the elevator. This is the socket. And this elevator is applied between, this is the bone, that is the interseptal bone, and this is the tooth. And this elevator, let me use some different color. This is the elevator which is applied between the tooth and the bone. So this is kind of wedging. This is kind of a wedging the tooth and the bone. Okay, so this is how you're going to luxate the tooth. So this is the wedge principle. The example of the wedge principle is apex elevator, and the mechanical advantage is 2.5. This is very important. This is asked in Viva. In lever, we have mechanical advantage of 3, and in wedge principle, we have the mechanical advantage of 2.5. Okay, and its application, where the elevator is inserted, it is inserted or it is applied between the bone and the tooth. Okay, this is how it is inserted. This is the picture. Okay, now let's see wheel and axle principle. In wheel and axle principle, the effort is applied to the circumference of the wheel. The effort, where you're going to apply the effort is applied on the circumference of the wheel, which in turns the axle so as to raise the weight. Okay. Now, how you're going to increase the mechanical advantage? Let me use this color. Okay. So greater the diameter of the wheel, if the diameter of the wheel is greater will be the mechanical advantage. Greater the diameter of the wheel, greater will be the mechanical advantage. So how much is the mechanical advantage we have in wheel and axle principle? Here the mechanical advantage is 4.6. This is asked in Viva, star mark. And these are the examples of the elevators which work on wheel and axle principle. These are crossbar elevators and crier elevator. Okay. I hope this wheel and axle principle is clear. What is the mechanical advantage? How you are going to increase or decrease the mechanical advantage? What are the examples of it? All these are the questions which are asked or which come from this section. Okay. Now let's see what are the elevators. So we have the following elevators. Let's study one by one. First of all, we have straight elevator. Okay. So just see the picture. This is the straight elevator. This is the concavity. This is the straight elevator, and this is the concavity. This side is concave, and this has the serrations. So these are the serrations, and these serrations, when you are applying the elevator, this should face the tooth. It has the serrations like this. Okay, so this is the straight elevator. Okay, now let's see its function. It is used to extract mandibular third molar. Straight elevators basically used to extract mandibular third molar with distally curved roots. Okay, with distally curved roots, it is used to extract mandibular third molar with distally curved roots. And the force of application means where you are going to apply the force of application is mesial. Now let's understand the application of the straight elevator with the help of the diagram. So this is the diagram. I have shown you the diagram of the straight elevator, how the straight elevator looks, and it's the side which is concave. This concave side has a serrations and it is facing towards the tooth. Okay. Now, first of all, while you are using the elevator, it is very important to know which is the thing from where you are using the fulcrum. You will never use adjacent tooth as a fulcrum. Okay, so this is the finger, this is my finger, this is the point of the elevator, this is the blade. The blue color structure, the blue color line is a socket, and this red color structure is a tooth. So it is very important, my students, you will never use adjacent tooth as a fulcrum. Okay, otherwise you're going to luxate that tooth also. So just keep a finger there as shown in the picture. Use the finger as a fulcrum. Okay, and then insert the elevator while luxating the tooth or removing the roots. Okay, so this is how you're going to insert or apply your elevator while you're extracting the tooth, and you are using the finger as a fulcrum, not the adjacent tooth. I hope the straight elevator is clear. Straight elevator basically used to extract the mandibular third molar with distally curved roots, and where you're going to apply the force, you were going to apply the force mesially. Okay, and this is the picture of the straight elevator. I hope now you'll be able to identify the straight elevator and also be able to tell the uses. Okay, now let's see Coupland elevator. So this is a picture of the Coupland elevator. This is the handle, this is the shank, and this is the blade. Okay, it has a concavity like this. In straight elevator, you saw the concavity along with the serrations. Serrations are there, but in Coupland, there is a proper concavity. There is not serrations. So this is how you're going to differentiate between the straight elevator and the Coupland elevators. I hope you'll be able to identify the straight and the Coupland elevator. Okay. Now, Coupland elevator is used to luxate or elevate the fractured roots of maxillary anterior teeth at the crest level. This is very, very important. At which level you are going to elevate or luxate the fractured roots of the maxillary anterior teeth? At the crest level by wedging action. As I have already explained you the wedging principle, while I was explaining you about the wedging principle, I have already explained what are the elevators that work on this principle. So here I am repeating again, Coupland elevators are the one that work on wedging principle. Okay, so it basically used to elevate the fractured roots of the maxillary anterior teeth at the crest level, or I could say at the cervical level. Okay, so just let's understand this picture. This is the broken piece of the root. This is the broken piece of the root. Okay, and this is at the crest level. See the level. This is at the crest level. Okay, this is your this brown color structure. This is your Coupland elevator. So this is how you're going to apply your elevator. This is the concavity or the concave part. Just focus here, my students. Just see the application of the elevator. When you are removing or luxating the roots, the concavity, it should always face the root surface. It should always face the root surface. And this is the point of application. This is how you're going to apply your elevator, in this direction. And when you are going to, by wedging technique, you are basically wedging between the root surface and the interceptal bone, and this concavity is facing towards the root. Okay, so this is you are going to apply your elevator, and when you will apply, this root will come out. Okay, so this is the application of the Coupland elevator. Okay, so now come back to this point of application along the side of the root surface in the periodontal membrane space. Okay, in the periodontal membrane space. I hope you understand the periodontal membrane space. If not, let me explain you. Suppose this is the socket. Okay, this is the root piece. Suppose this is the root piece. Okay, can you see the space between the root surface and the bone? This part, this space, this space is periodontal space. Okay, this is the periodontal space. So the point of application is alongside the root surface in the periodontal membrane space. Okay, I hope the Coupland elevator is clear, and you will be able to identify the straight elevators and the Coupland elevators, and you will also be able to tell the application, how you're going to apply the elevator while luxating the root or the tooth. Okay, now let's understand apexo elevator. So there are two types of the apexo elevator, straight and the curved. So here is the picture. Let me show you the picture first. Okay, so this is the straight elevator, this is the curved elevator, these are the curved elevator, and the curved elevators are paired. Curved elevators are paired. This is the straight elevator, these are the apexo. Curved elevators are paired. Okay, now let's see the use of the straight elevator. So a straight elevator is used to luxate or elevate the fractured apical third of the maxillary anterior teeth by wedging technique. These are basically used to luxate the remaining apical third of the maxillary anterior root. Earlier in the Coupland elevators, we learned that it is used to elevate or luxate the maxillary anterior root at the crest level, okay, at the crest level. But now the straight apex elevator is basically used to luxate or elevate the fractured apical third of the maxillary anterior teeth. See the picture. Earlier, the Coupland elevator is luxating the broken root piece at the crest level, and now look at this picture. Here the straight apexo elevator, it is elevating or luxating the broken pieces of the root at the apical third, means the remaining apical third part or the piece is removed by the straight apexo elevator. Okay. Now the point of application. Let's see the point of application. Along the side of apical third of the root surface in the periodontal membrane space. I have already explained you earlier in the Coupland elevators. Now let's see the picture. This is the apexo straight elevator. Okay. Now let's see the curved apexo elevator. The curved apexo elevator, it is used in the removal of fractured single roots after separation. It is used to remove the fractured single roots in maxillary posterior teeth and mandibular teeth. Okay, in maxillary posterior teeth and in the mandibular teeth. Since curved apexo elevators, they are paired, so it is very important to know that it is of the right side or the left side, or it is going to be used in the first quadrant or in the second quadrant. Okay, so let me just explain you how you're going to differentiate. First of all, when you are using the curved apexo elevator, just take the elevator in your hand in front of the patient and just see if this concavity while you are holding the apexo curved elevator in front of the patient, and just see if the concavity, suppose you are drawing the quadrants. Okay, now see if this concavity is facing towards the second quadrant, means this side will be the second quadrant, right? If it is facing towards the second quadrant, so it is going to be used in the second quadrant. Okay, if while holding the elevator, if the concavity is facing this side means towards the first quadrant or towards the right side, so you're going to use it in the first quadrant. So this is how you're going to differentiate between the quadrants or right or left. Okay, I've already explained you this concavity should be towards the root to be extracted only. Just make sure this is a star mark point. This concavity will always be towards the root, towards the tooth to be extracted. Okay, this concavity should always be towards the tooth to be extracted. Okay, I hope now you will be able to differentiate that whether this curved apexo elevator you're going to use it for the first quadrant or for the second quadrant. Okay. Now the next elevator is a Warwick-James elevator. It is also a paired elevator. It is also called hockey stick elevator because its blades are like the hockey stick like. So it is basically used primarily luxation of maxillary third molar with distally curved roots, and it works on the liver principle. Okay, these are important. These can be asked in your viva. So just remember, it works on the liver principle, and these are also called hockey stick elevator because of its shape of the blade. Okay. Now we have Cryer elevator. So its blades are triangular in shape. As you can see, the blades are triangular in shape. It is introduced through the empty. So how you're going to apply the cryo elevator? It is basically used in the multi-rooted molars. If one or the single root is remaining in the socket, so it is basically used. So cryo is used to remove the roots. So it is introduced through the empty socket. So how you're going to apply it? It is introduced through the empty socket of one root of multi-rooted mandibular molar to engage and remove the interseptal bone and the other remaining tooth. What does it mean? Suppose the mesial root is removed, only distal root is remaining. So how you're going to apply it? You are go with your cryo elevator, you'll insert it in the empty socket. Means if mesial root is absent, it has been removed already, you're going to apply your cryo elevator in the mesial socket and then you'll remove the distal root. So this is how you're going to apply your cryo elevator, and it works on wheel and axle principle. It basically work on wheel and axle principle. Okay, and very important question, this concavity, it should always be towards the tooth to be extracted, or towards the root or the fragment pieces to be extracted. Okay, now we have crossbar elevators. It also has the same function. It is basically used to remove the one root of the multi-rooted mandibular molar, or in order to remove the interseptal bone. The only difference is it is of T shape. Whenever you are asked the difference between the cryo elevator and the crossbar elevator, there is a difference in the design. In crossbar elevator, it is of T shape, and here in cryo, the handle and the shank, they are in straight line, I mean they are parallel, while in crossbar, the handle and the shank, they are at 90-degree angle. They are making a 90-degree angle. So this is how you're going to differentiate between the cryo elevator and the crossbar elevator. I hope you will be able to identify each and every elevator and tell the function and its application and on which principle it is basically working. Okay, so both the cryo elevator and the crossbar elevator, they work on wheel and axle principle. Okay, so that's it for this video. I hope I made your doubts clear. So do share it with your friends, and do like my video, share it with your friends, and subscribe to my channel. So let's meet in the another video with another topic. By the time, thank you so much.